All right. Number 25. That going. These are review questions. Y equals e to the negative x over 2. Y equals 0. X equals 0. X equals k. That's fun. Where k is greater than 0. So, if I plug in 0, e to the 0 is this. By the way, if I plug in 1 or 2 or 3, this is going to be decreasing. This negative means it's going to decrease. And then k is just arbitrary. Somewhere here is x equals k. And then this is the area they're talking about, from 0 to k. So if I set this up, it would be from 0 to k. To find the area, top subtract bottom would just be e to the negative x over 2 dx. And then to actually do this, the hook comes from this, that's negative 1/2. What it was over what it became, I need a negative 2, or 1 over negative 1/2, which is negative 2. So the answer is negative 2 e to the negative x over 2 from 0 to k. And then I plug in k, subtract, plug in 0. And e to the 0 is 1 or plus 2 at the end. 26, we're going to find the volume of the same thing. So I'm still integrating by revolving around the x-axis. That's a circle. Again, top subtract bottom is just e to the negative x over 2. Clean this up a little. 2 times this just leaves me with e to the negative x. The hook is negative 1, so I need a negative pi. And then you plug in k, subtract. Remember, when you subtract a negative, you're adding, and then plug in 0, which just leaves me land with pi. (27). If we go about the y-axis, this is going to be the shell method. The radius is just the x-coordinate, and the height is the function, which is e to the exponent negative x over 2. You know what we're going to have to do here. So we're going to do it by parts, aren't we? Yeah. So we got to integrate this by parts. I'm really excited. We got to do this. If I integrate this, didn't I already integrate this way up here? So when I integrated e to the negative, what answer did I get? I got negative 2 e to the negative that. So negative 2 e to the negative x over 2. The formula is uv minus the integration of v du. Going to clean this up. A negative times a negative is positive, and the 2, I'm going to put that in front too. This is negative 1/2, which means I need another negative 2 here. again, I'm integrating from 0 to k. I'm going to continue here. So I have 2 pi. I have negative 2x e to the negative x over 2. Subtract 4. And then ignore the hook, and then it's just e to the negative x over 2. And that's from 0 to k. Plug in k for x. Don't make it complicated. And then plug in 0. E to the 0 is 1, but 0 times anything, that's 0. Minus 4. E to the 0 is there, so it's just minus 4. So like a minus minus would make it plus 4. That's it. Alright, 28. Three x squared minus 2y squared. 4xy plus 20. I want to take the derivative of that. I'm going to do it implicitly. So the derivative of 3x squared is 6x. Whenever you take the derivative with y involved, it needs a hook y prime. This is going to be the product rule. That's the first times the derivative of the second plus the second times the derivative of the first. And then the derivative of 20 is 0. All the y primes need to be on one side of the equation. So I'm going to subtract 4x y prime. And I got 4 times y, and I'm going to subtract 6x. So the y's are on one, y primes are on one side, and what doesn't have a y prime is on the other side. Factor out a y prime, and then divide. Number 29. Oh, find the points in problem 28. Vertical tangents. So a vertical tangent means where the derivative is undefined, because the slope of a vertical line is undefined. So where is this undefined? Only look at the denominator. Make it equal to 0. And then solve it. So I'm going to add 4x. I'm going to divide by negative 4. So y is equal to negative x. And then I'm going to go back into the original equation. And wherever there's y, I'm going to put in negative x. So I go back into this equation. Wherever there's a y, I put in negative x. I'm going to simplify this. I'm going to add 4. It's hard to believe. Divide by 5. So the answer is either positive or negative 2. If the answer was positive 2, then y would be negative 2. If the answer is negative 2, then y would be positive 2. So at these 2 points, 2, negative 2, and negative 2, 2, it's undefined. Kind of a fun question, right? Number 30. Find the equations of lines tangent and normal to the graph, problem 28, at that point. So they give you a point, negative this. So I need to know 3 things: the x coordinate, the y coordinate, and the slope comes from the derivative. So I need to write down the derivative again. I just threw it away. So the derivative of 4 minus 6x, 4y minus 4x. And then I'm going to plug that in here to find the slope. We got this. So where there's a y, I plug in 0. And where there's an x, I plug in negative root 2 over 3. Again, y is 0. Look, these divide out, and it leaves me with positive 3 over 2. It looked worse than it was. And then what's the tangent line? So it's y equals the slope, x plus the square root of 20 over 3. And then I don't need to go plus 0. The normal line, almost the same, but normal means perpendicular, so I do the opposite and reciprocal, and everything else is the same. And there are my lines. Number 31. All right, find a general solution. This is called the differential equation because we have a derivative there. Step 1 is to change that to dy by dx. I'm going to add the cube root of x to the other side. I know I need to separate the variables. It'd be helpful at this point to make it calculus friendly, to write this as the exponent 1/3 and to write this as the exponent 1/3. And then it's actually pretty simple. You just add 1 to the exponent and then the reciprocal instead of dividing. Add 1 to the exponent and then the reciprocal. And that's a good answer. It didn't say to solve for y. And there you go. 33. 32. Find the particular solution. 2x, y, y prime. So I'm already going to write this down. All right. So write it down. I want you to solve this diffie q. And then only press play when you need the next step. So obviously the first step is to separate the variables. So I multiply by dx. Then I'm going to divide by 2x. In fact, I might just keep 2y here and just divide by x. I see something. So if I keep 2 here, it's easy to integrate. It's just y squared. That's easy. And then I see something here. I see 1 over x to be able to do it here. So the integration here is y squared. On this side, if you see 1 over x, the derivative of ln x is 1 over x. So the hook is there. So it's just ln x squared plus c. Next, take the square root. The answer could be positive or negative. When I look at question number 32, the point is e and 1. So because the y coordinate is positive, we're going to use the positive value, and this is equal to 1. Ln e is 1. That's just 1/2. Square both sides. Subtract. 1 take away 1/2 is 1/2. And then come back here, and again it's the positive 1. Plus 1/2. Number 33. What we practice regularly, we're going to learn. So y at 0.6 is what my goal is. We start with y at 0 equals 2. And it says y prime is equal to x plus y. So if I start at 0, how many steps? It says 3 steps. So if all it tells you is 3 steps, to find the change in x, we're going to go 0.6 take away 0 and divide by 3 steps. So that's where I get my change in x. I need that. It's 0.2. Then I'm going to draw a chart. This is going to help organize the information that I need. And my goal is to get to 0.6. So I start here. It's 0 and 2. The derivative is you add them together. And then to find the change in y, we take the derivative times the change in x, which is 0.2. 2 times 0.2 is 0.4. And then I keep going. So the change in x is 0.2. So I add 0.2 here. To find the new y value, I take 0.4 and I add it to 2. I can do that. And then I add them together for the derivative. That's 2.6. Then I take the derivative, 2.6 times the change in x, which is 0.2, and that's 0.52. I don't blame you for using a calculator to multiply it, but ultimately all you're doing is doubling 26. That's where 52 comes from, and then move the decimal twice. All right, now we're bumped up to 0.4. Take 2.4 plus 52, 0.92, right? The derivative is to add them together, 3.32, and then take 3.32 times 0.2. So my advice again is to double this answer. That's 664, and then move the decimal 3 to the left. All right, this is it. This is what we came for, right here. Take that answer and 0.664. I don't blame you if you have to. And that's the answer I'm looking for. So what's the approximate answer? And I got 3.584 using Euler's rule. Number 34. That was it. No number 34. Woo! All right, Mr. G Math, over and out. Till next time, I'm so proud of you that you did your homework. Don't give up. Till next time.